In working on topic 4 of module 5, we're going to look at some word problems and then later solving some formulas. So what we need to do here is to read this problem over, and we're going to work on this particular equation, which is the distance formula. And what we can work on too is we want to find out if we solve the distance formula for t, what would it be? And that's going to be very useful in working this out. So we're going to read, reread, see what we can come up with. So here we have the formula distance equals rate times time. If we divide both sides by r, we get time equals distance divided by rate. And that's what we're going to do down here. Let me help you set it up just a little bit. We're going to have distance divided by rate equals distance divided by rate. Now this is time. That's what t is. T is distance divided by rate. This is distance divided by rate. And we want our time to equal time. So let's see what we come up with. So as we look at this, we know our distance is 240. Now we know the rate for one is going to be r. Again, we don't know specifically what that is, but we know the rate for the other is going to be 20 miles an hour faster. So this rate, in a sense, is r plus 20. Now we know this is time equals time, but they don't equal the way they are here. For instance, if this were 4 hours and this was supposed to be 4 hours, let's say it's going to be faster because they're going faster, would be 3 hours. What would we have to do to get our times to equal each other? Now it says 1 hour less if they went faster. So this is less time here. In order to get the times to equal each other, we'd have to add 1 hour to this time. So this is time, but it's less time. In order to get the hours to equal each other, we'd have to add 1 hour to this side. So for example 1, this is our problem. Now what we need to figure out here is how do we solve it? And that's what we're going to do. So we had in an earlier lesson, we could modify this equation by multiplying every term by the lowest common denominator, which is r and r plus 20. So we'll put that out here, r and r plus 20. Now we're going to get a new equation that we'll put over here. So here the r will cancel with the r, and we're going to multiply r times 240. Now 20 times this is 4,800. So that now will equal. Now as we multiply this one here, this cancels out, and that cancels out, so we're just going to get 240r. This canceled out, but we have to multiply r times 240. And then for this next part, nothing cancels out, but it's 1 times this, so I'll distribute that. That's r squared plus 20 r. So we have an equation that's sort of spread out here a little bit. So we're going to, it's a quadratic equation, put it in standard form. So I see here that I can subtract 240r here and 240r here. So these just go away. And I want to put that in standard form, so I'm going to put my r squared there, my 20r there, transpose this is a negative 4800. And now I have it in standard form. Now, interestingly, this will factor. And I'll give you a moment to see what you can come up with. Now, as I played around with this, I saw that 48 is 6 times 8 is 48. And since we have a couple of zeros there, I tried this, and this works. So I need a 20 for the middle, so this is going to be a plus 80, and this will be a minus that. So when I solve these, I'm going to get r equals 60, or r equals a negative 80. Now here's a case where we use a quadratic equation and we get a value for rate. I had stuck an x there. As being negative 80. You can't have a rate like that. So we reject this answer and find Horace's average speed. Well, that's what r is. So his average speed is going to be 60. And here, this would be 60 plus 20 would be 80. And 60 divided into that is 4. And 80 divided into that is 3. And there's our extra hours. So actually, when I had done this before, and I kind of remembered this analogy that I made here, and it happens to work out. So again, how did we do this? Well, reading it carefully, using the distance formula, we're trying to get time equal time. And we said that time is distance divided by rate. So here we had to add more time so that the distances, so that the times were equal. All right, that's example 1. Now for these, we have formulas in which we are to find a particular letter. Here we want to isolate the G. So we want to isolate the radical by dividing both sides by 2 pi. So then we get t over 2 pi. These are just going to cancel out. And we get this equals the square root of L over G. Looks like a 1, but it's actually the letter L. Now, going into our toolbox, what tool do we have to get rid of the radical sign? Well, remember there's a 2 there. So if we square this side and then square the other side, the radical sign goes away and we're just left with L over G, but then this becomes t squared over 4 pi squared. Now we have to square the numerator and denominator. Now we're looking for L. No, we're looking for G by itself. So remember, when we have fractions like this, we can cross multiply. So we're going to get T squared G from multiplying these two, and we get 4L pi squared, multiplying these two. And we want to solve for G. So we divide both sides by T squared. And there the T squares cancel out. I'll save a little room here. And we get G equals that. Now, as we look at this next formula, we want to solve for the letter T. Well, we have T squared and a lowercase t. For this, we could actually use the quadratic formula. But we're going to change the letters a little bit here. We're going to say T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we have to identify what is our a, what's our b, what's our c. Now in order to do so, we must put this in standard form. So this will be 16t squared plus v of o, and that's initial velocity. Transpose our s to the other side, it becomes a negative s. And now we'll outline our letters here. This is our A, this is our B, and that's our C. So we're going to get T equals negative B, well it's a negative V sub O, initial velocity, plus or minus the square root of b squared, which is going to, we have to put this in parentheses now, minus 4, a is 16, and c is a negative s. And that's all going to be over 2a, which is 2 times 16, 32. So let's clean it up a little bit. T equals negative v sub o plus or minus the square root. This is still going to be v sub o squared. Now we have to put that in parentheses because these are two letters involved in a symbol. So if you don't, then you're only going to square this sub o. So putting it in the parentheses is needed. Now here we have a minus times a minus. So this is going to become a plus, which makes it a little easier to handle. And 4 times 16 is plus 64s. 4 times 16 is 64s all over 32. And that's the answer they have down below. And a use every once in a while for the quadratic formula. Okay, for this one we want to solve for c. And the first thing we do, get rid of our radical sign, and we just square both sides. So we get w squared. Now squaring something that has an index number of 2 to the second power just gives us our radicand. Now, since they're fractions, we can cross multiply. W squared LC equals 1. And we want to solve for C. So what we do here is divide both sides by the letters we don't want. We don't want the W squared there, and we don't want the L. So W squared L. Here they just cancel out, and we get C equals 1 over W squared L. And these are our answers. Now again, what you want to do is try these on your own. And if you're reviewing using this tape, you go back to where there's no answer, you try it, and then if you need the help, you run that part again. Remember, you could fast forward and rewind as needed. And don't forget, you can ask questions. Now, these examples weren't in our book initially. I've added them just to give us a little more practice. So what I'd like you to do, we're going to pause, and you can work on them in your booklet. In fact, we may give different folks a little classwork assignment to see if you can come up with an equation for these 4 word problems. We're not going to solve them, just coming up with the equations, and I'll put them up one at a time, and we'll see how you did. Okay, you needed to recall what we did a little while ago, where we're going to use the distance formula. Distance equals rate times time, and we want to work with time. So time is distance divided by rate. So during part of the trip, she went this distance divided by her regular rate, and this stands for a portion of time. Then she went another distance, but her rate was a little slower. But her total time is 5 hours. So in a sense, this is a portion of time plus a little more time equals time. So in a sense, this is like a sub 1, and this would be a sub 2, and this would be a sub 3. But you see it laid out. All right, let's see what we did. And this is a similar problem. Again, it's going to be time, which is distance divided by rate. So here we have distance divided by rate. Now, we don't have the other distance, but it's the same actually. But we know this other rate is going to be 10 miles an hour slower. Okay? 10 miles an hour slower. So in order to get these equations to equal each other, we're going to have to add an hour. Now, students sometimes wonder, which side do I add an hour to? Now, here, since you're going slower, this is going to take more time. So to have time equal time, we have to add the hour to this side. And again, study this. This is the equation, and we did one. Our first problem in this lesson was how to do this. All right, for number 3, again, after reading it carefully, it's similar. 500 divided by R is a time. 1000 divided by R plus 75, this is time also. But this is a time that's going faster in order to check out the speed, this time took an hour longer. That's what it says. Now, to make this then an equation of time equals time, we have to add that hour to this side, because this already is taking an extra hour. To get this to be equal, we have to add the time to this side. And again, I know for some students, this is a challenge. You may want to add it to this side. But this is already taking more time. 1 hour more. So this took less time. So to get time equal time, we have to add time to this side. And we did one like this earlier as well. So there's distance divided by rate plus distance divided by a slower rate. And again, this is time plus time equals the total time for the trip. Now, we might say, how do you solve this? Well, you're going to have to multiply this by the lowest common denominator, as we did earlier, and all of these are done in a similar way, which will be r times r minus 2. You multiply each term by this, get rid of our fractions. These generally are quadratic equations. Sometimes they'll factor, sometimes not. But you can always use your quadratic formula. But here we're more interested in seeing if you could get the equations that are generated by the words, and then eventually you would have to solve them. Okay, that'll wrap this up.